Hello and welcome to this repair tutorial, and today we're going to look at a Cambridge Azur series, and this is the 640A and it's the version 1 unit or amplifier. Just for people who are probably unfamiliar with this series of amplifier, there's also a 640A version 2, and it underwent a number of enhancements for the version 2, but you can quickly identify it. Not just from the fascia, because there's some additional sort of legend writing on the front, but just when you turn the amplifier around. On the version 1 you didn't have a main switch on the rear, but on the version 2 you had the ability just to turn off the power from the rear. But as we say, this is a version 1. So just general specifications on this unit. So power output is 65 watts per channel, and that's into an 8 ohm speaker load, but this increases up to 100 watts if you have 4 ohm speakers. And then frequency response is 5 hertz to 50 kilohertz with excellent total harmonic distortion of 0.005%. And then for the inputs, these are what we term as the line inputs. So this is the auxiliary, CD, tuner, DVD and AV, and also tape is at 380 millivolts. But what you did have is the option to feed a phono board, and we'll sort of come back to that, because actually this amplifier did indeed have the moving magnet phono board installed, but its input then is 1.75 millivolts, and the amplifier provides a preamplifier output. So if you want to connect the amp, for example, to other power amplifiers and run them all simultaneously, or just use this unit as a preamp, you can if you wish. And then the tape monitor output as well. And then from the front you can select speaker set A and B, and of course you have 4 speaker terminals on the rear. And then in terms of dimensions, width is 430 millimeters, depth is 320, and 100 millimeters then for height, and then weight is 7 kilograms. Now the amplifier also comes with a remote control. Sometimes over time these sort of go missing, but Cambridge used exactly the same, shall we say, codes with regard to the signals which are sent between the handsets and the amplifier. So it's very easy to pick up, another Cambridge amplifier remote and use it with these units, or get a clone or clone remote control. And then individual tone controls. So you have your bass, treble, and then balance controls. And then also motorized volume control as well, and you also have the headphone socket on the front, and the ability to go direct mode. So what we mean by that is you just bypass the tone control circuits, and on off for the amplifier, permanent power being applied unless you switch it off from the main supply, and then the operation is via the push button just at the front or the remote control. So what was the issue when this amplifier came into the workshop? Well, the report from the customer was multiple. The first one was that if the customer switched it from the front panel, sometimes you got almost like a key bounce. So sometimes it wouldn't sort of power on, power off, or maybe you try to power it off and then it sort of flick back on again. And that's very common, and we'll sort of get into the reasons for that in a moment. And then the other one was that you kind of got intermittent loss of sound, and sort of slight distortion also on the speaker output terminals as well. But before we sort of look at that, what was sort of like the initial sort of inspection? Well, when you look from the top cover plate, and unfortunately for this amplifier, what had happened was, I think it had a previous owner, and the right hand corner fixing screw for the top plate had become threaded, but it's not actually the brass insert which becomes threaded. What happens is the brass insert just becomes stripped within the plastic molding. So when you try and remove these sort of torque screws, you just can't get them out. Okay, so in this case, before the top cover could be removed, the top had to be very, very carefully then drilled out. What I would say to people is, if you're going to kind of do that, either get yourself a hand drill, because you need to avoid slipping and sort of drawing lines on the top of the plate with a drill bit, or as in my case, I just use a flatbed driller to put it on a low speed, get a high precision drill bit, and then I could just very, very precisely just drill off the top of the head of the torque screw to the point then which the lid then came away, and then I just simply replace the brass insert. I'm not interested in removing the sort of the drilled off screw head, and then put a new insert in place. It's all bonded in position, and everything was fine then for the sort of reassemble. So when you looked inside the amplifier, and I'll sort of highlight that now in the video, what you can see is that the amplifier had installed the I'd sort of say famous Cambridge audio phono module, and these can be retrofitted. So if you can source them even with an existing amplifier, you can also use this with the version 2. You can simply cut 2 wide links at the back, and then once those links are cut, it will then route the audio signal from the turntable directly into the phono board, and it picks its power up and all the necessary signal ins and outs when you plug it into the board. What you'll have as well is just a small locking nut that you just put onto the one corner, but I'm not sure if the customer was aware that they actually had this board installed. It did say on the rear that it was installed, but sometimes you can get these amps in for repair and you just take the lid off. There's no initial indication, and it's kind of, you find a bit of a jewel by the fact that these boards are installed. So just sort of highlighting that. Now there's a lot of dust inside the amplifier, but you know, not kind of unexpected. So again, use your practice, you know, clear it out with a compressed air line, stiff brush, and just get as much of that out of there as you can, because of course you're going to then start to sort of undertake your fault finding. Now the next thing that I want to sort of highlight here, and you can see it, is I've just taken a snapshot from the service manual for the front panel board. Now the front panel board does a number of things. It actually contains the microprocessor, and this microprocessor of course contains firmware code which is loaded into there by Cambridge Audio. And not only does it take care, for example, of receiving the signals from the Cat5 protection system, but it also will take in all of the command signals from the remote, and via the necessary interface components it will also drive the command signals out to increase and decrease the volume control, and via the appropriate components as interface components it will drive the respective LEDs on the front to verify that the inputs, whichever the customer chooses, has been selected. And the same micro, which is always very common, will also read directly the input switch coming in from the fascia, and it also will read the standby switch, which is the power on switch for this version of Amplifier, because there's no rear switch as we mentioned. Now what I want to sort of show you here is really a side view of that switch, which is for the standby, and there's a couple of things that I want to sort of highlight. With all of the switches on these amplifiers, what Cambridge Audio did was it just put like a self-adhesive sort of sponge sort of washer. I'll refer to it as that, and the reason for that is that it sort of provided almost like tactile feedback when you press the buttons. If you didn't have it there, literally these plastic buttons would kind of almost sort of semi-rattle around and become loose. But the reason why I'm highlighting this, and then I also show here all of the input selection push buttons have been removed, and then what would normally have these washers on there. What happens over time is that literally these washers disintegrate. So if you remove the buttons, if you even literally like you just touch them with your fingers or a bit of rag, it almost sort of dissolves into almost like a thick oil type substance, completely breaks down. So what you have to do here is to replace them, and then what I do is I fit neoprene washers, and I'll show the example of that here in the video. And what you can see here is one of the, or this is the standby push button, has replacement neoprene washers on there, and they are excellent, really good neoprene washers. You slip them over depending on how many you need. Often it's just 2 of them, and really good positive results. So if you're working on these amplifiers and you kind of, you know, you're going to do some restoration work, just be aware that you will need to sort of replace these foam washers. very, very common. Now, let's come back to this other issue which we spoke about, which is where the customer reported when they pressed the front standby button, sometimes it would work or they get key bounce. Now, the reason for that is that the PCB mounted miniature push buttons just become worn. So what I show here is the back of the circuit board, and on there you will have the LED, which you see from the front fascia, and there's also the 4-pin, but it's a single pole contact switch, and it just becomes very, very badly worn, and that's what you find. So again, what I show here on the video is you can see the push button, you know, with the old foam, which is sort of disintegrating, but then you can see the small little push button there. And these are readily available. You know, you can buy these from any component supplier. You know, they're 5mm by 5mm, and then the only other thing that you need to check is just the plunger height, which is the black button that you see on the top. Just, you know, measure that from the bottom of the switch casing. It's 6 by 6 by 5, and then verify you've got the correct one. And then once you desolder that, it's just a straightforward task of then replacing it to really eliminate that issue then of the key bounce. It's nothing more than that, and once you do it, you'll have very, very positive tactile feedback when you operate it. And because of the age of this amplifier, what I then did is, and I'm sort of again showing you here in the video, I'm showing you the control panel, which is the one where I said with the microprocessor on. And the reason why I'm showing you this is that you can see the input selection switches on the board with the LEDs just above there, and then the component which is mounted into the socket with the white sticker on, that is the microprocessor with the firmware code on there. So it's quite straightforward, and what I would say is sort of just remove the fixing screws on the bottom plate, so you're able then to release, they're like spring pillars, plastic pillars, so you can lift up the tone stroke input board, and then once you pull the fascia forward, you'll be able to gain access to the multiple fixing screws which hold it in place. So as I mentioned, I just replaced with the neoprene or fitted neoprene washers, and then replace those push ones, just because, you know, they were worn, and you know the customer doesn't want sort of issues when the amplifier then goes back into service then. So that was that issue. So the second one is the intermittent loss of sound. So the most common issue is due to the speaker protection relay contacts becoming heavily worn, and they become oxidized as well. So what I show here in the video is the speaker protection relay that you can see here, and just as a matter of course, whenever I have these amplifiers in, I will replace those relays. Now I have exactly the same make and model in stock, so I'm not fitting a generic part. I fit exactly the same, or what I would term as genuine original, into there, and then that would then take care of any intermittent issues from the switching contacts. Effectively, it just eliminates that. And then the other thing which I want to sort of bring to your attention is that exactly the same relay on the version 1 series, and this could be the 640 or the 540, is used for the power selection to the toroidal transformer. So when you plug it in, you have a small DC supply which will provide the power then to the microcontroller, so it's permanently on, i.e. it's in standby, and then when you hit the remote or you press the standby button on the front, the microprocessor will send the command signal to the transistor on this board, and in turn it will then operate that relay there. Now you can imagine how many times that relay operates over the life of an amplifier, and again the contacts become worn and oxidized, and sometimes you can even got sort of like random tripping, you know, the protection circuit, or pretty lousy startup. So what I do here is I just replace that relay completely. A brand new relay goes in, and again what I've done here is I've just eliminated another potential issue which during the test phase of the amplifier, you know, I'm not going to see any issues related to that. So that's really, you know, 3 things that was the issue on this amplifier, plus some additional work with regard to, you know, and adding some longevity in. But there is some more work then to be done. So next work, and this is done as a matter of course, was just to verify that there was no sort of bad solder connections or aging type solder connections. So what I'll show next is the tone control stroke input board, which has sort of been removed, and it's sort of turned on top of the main amplifier board. So you can see here I'm just using a thick cloth so that there's no damage to the fascia. And then up towards where the signal generator and the multimeter is, you can see some discoloration there. Now that is perfectly normal. It's not, abnormal. But you will get this in amplifiers. You'll get certain areas where it's running hotter than others because the circuit, it could be more of a power type circuit. But whenever you see this, you got to verify to make sure that you haven't got any dry joints. So just go through there and resolder them. And also on the user controls and switches, often with these Cambridge amps, you can get sort of dry joints as well. So all the boards are checked, and then all necessary suspect joints are then reflowed. Now, once that was done, it was really kind of semi-assemble. So I don't do a complete reassemble. What I'm looking to do next is just to test the amplifier and run it through. So under initial test, what you found was on the CD input, what you found was that the left channel was intermittently lost. So sometimes it would work, and then sometimes it kind of wouldn't work. And you're looking at this thinking, well, okay, could be a number of things. It could be, for example, that you have some broken connections around the RCA socket. But just to verify if it's localized to that input connection, dead easy. So if you're doing the repairs yourself, just remove both input leads to the Phono inputs, and then just move them then to another input and then test it. And all the other inputs were working fine, just the issue with the CD input. So what I'm showing next is the solder side of the circuit board, and what I think here is that this became a secondary issue due to the primary issue, and I'll elaborate what I mean here. So the secondary issue, this here was caused by what the actual fault was, which was a faulty RCA socket. Okay, so the contacts inside the RCA socket at some point in time, was making an intermittent connection with the plug, and I kind of figured that maybe the owner found this as an issue and then probably put some extra mechanical stress on the leads trying to find out what was going on, and then it created this second problem, and this is not uncommon. What I'm showing here, and it's probably not immediately obvious, is that there is cracking around the circuit track to the point on one or two of them it had almost broken away from the board. So what you have to do is you have to desolder the solder connection, but as I've said many times, don't just flow some solder over there. It's not going to be mechanically strong enough. So use some link wire, wrap it around the terminal as it comes through, and then connect it then onto the board. You just have to scrape a little bit of the coating off to expose the copper for the circuit track, and then flow that link onto there, and that will provide you with a very, very strong mechanical contact. So that was done first, and again it was retested, but the issue still remained. So it's just a case then of replacing the RCA socket, and this is a two pin, one for each channel, so it's 4 in one single unit, and again replaced with genuine original. And once that was replaced, there was no issue at all with any intermittent loss of sound on the left channel for the CD input. You can also see on this photograph here what there are is the links. You can see there's 2 links which have been cut on the board, and those are the links that need to be cut if you're installing the moving magnet board that we referred to a little while ago. So once that was all done, what's kind of next? Well, the next part is to just clean up the user control potentiometers. So you spraying De-Oxit directly into the bass, treble, balance control and volume controls, and just rotating them multiple times until those tracks are all nice and clean. And then also into the selection switches as well. So this is the tone switch, tone defeat switch, and then also the speaker selection 2 switch, and also the headphone socket. And remember, when you were doing checking for dry joints, as we said on other tutorials, just verify mechanical stress. You might find some cracking around the headphone socket, or as we mentioned previously, the user controls. Just make sure that there's no kind of underlying issue there. And then once that is all done, what I'm going to draw your attention to next is the bias setting. And bias setting on these amplifiers is very, very easy to do. And also as well, it's not like some of the earlier amplifiers where you just had a single turn preset. Here on this series, what Cambridge did was they installed multi-turn preset. So it has 10 turns on it, and it makes adjusting the bias for each channel, extremely easy. So here we show the circuit schematic then for the left channel. So how do you start off to set the bias? Well, first of all, just make sure you're in a good environment, i.e. not a drafty environment. And then you can then leave the amplifier, running say for about 15-20 minutes. Your volume control should be at minimum. All of your user controls on the front, balance control, bass, treble, etc. So balance at midpoint, all the other controls at midpoint, that's fine. But ensure that there are no speaker connected or no signals applied. And then once you've done that, it's a straightforward task then to connect across the emitter resistors here. And what you're looking to do is just to adjust that millivoltage to 13 millivolts for each channel. And I actually show this in the video. So here you can see that I'm showing on the multimeter after adjustment 13 millivolts, or approximately 13 millivolts or thereabout. Once you've done the one channel, guess what? You just repeat it then for the other channel. And then what I would say is just leave it maybe for an additional 5 minutes. And then once that has then been completed, you can just verify and then recheck. And then the only final thing to do, as with all amplifier repairs, you can of course put the amplifier under a full load test and frequency check. But also this amplifier, just required cosmetically cleaning. And then also as well, what I will sort of highlight, but I'm not getting on my soapbox on this one, this amplifier at some point in time had been in an environment where maybe someone was smoking. So the reason why I mention that, and I have on previous tutorials, for repair technicians or people doing repairs, the nicotine which gets coated onto the circuit board also coats the user control potentiometers and internally the switches. And that means that you will have to spend a considerable amount of extra time just working through that, right? Because it just gets everywhere. And sometimes with the user controls or even the switches, it's just not possible to clean them internally. Sometimes there's nothing you can do, but you have to replace them. Thankfully, in this case, they didn't require replacing, but it did take quite a lot of extra work, to get them to where they needed to be, where they were noise-free and reliable operation then. So there you have it, all done and dusted. So if you have any questions, by all means email Audio Amplifier Servicing at aol.com, and I will be happy to respond back to you same day. Or alternatively, you can leave some comments if you wish. And I really appreciate you stopping by today, taking the time to listen. Until the next time, I wish you well. Cheers. Bye-bye.